We created one of the smartest inventions of the modern times, the smartphone. It's smart, it's useful, it's completely changed how we live. But here's the real question. The phone is smart, but are we smart about how we make it? Because building this ingenious device comes with a cost we rarely think about. Let's dive in. What we are smart about. We carry a tiny universe in our pockets. It talks to us, connects us, stores our memories, makes sure we don't miss a beat. What's this device actually made of? It's not just metal and glass. Each phone is built from around 75 different elements, mined, refined, and shipped from across the planet. That's more than half the periodic table, all working together in perfect harmony. We have become smart at designing the technology that makes smartphones tick. Layers of glass, metal, and code, all engineered to work seamlessly. So let's peel back those layers and see what's really inside. Most modern phones use Gorilla Glass, a tough aluminosilicate glass. Unlike ordinary glass, which is mostly silica, soda, and lime, Gorilla Glass begins with silica mixed with aluminum oxide and minerals that contain sodium ions. Then it goes through a process called ion exchange. The glass is soaked in molten salt, and larger potassium ions replace the smaller sodium ones on the surface. These bigger ions pack tighter, creating compressive stress that locks the surface together and stops cracks from spreading. The result is a screen that's thin but several times stronger than regular glass. Now for the layer that lets us swipe, tap, and pinch. Indium tin oxide, or ITO. It's a transparent conductive film made from two scarce metals, indium and tin. Indium is often a byproduct of zinc mining, and tin is mined as the mineral cassiterite. These metals are refined and turned into ultra-thin conductive films before being deposited onto our phone screens. Why is ITO so important? Because ITO conducts electricity. When our fingers, which carries a tiny electrical charge, touch the screen, it disturbs the electric field in that layer. The phone senses that disturbance instantly and turns it into a command, like opening an app or scrolling a feed. Ever wonder why our phone screens are so bright and colorful? It's all thanks to a few rare earth elements: europium, terbium, and yttrium. These elements act as phosphors, glowing red, green, and blue when electricity hits them. They are the reason TikToks pop, Netflix shows shine, and emojis come alive. Nearly all of the world's supply, about 97%, comes from China. Mining them isn't simple. It often involves separating them from radioactive materials, refining them, and shipping them off to factories where they are carefully layered into the screens. That ping, that favorite song, all powered by two rare metals, neodymium and dysprosium. These metals create tiny but mighty magnets, small enough to fit in our phone, yet powerful enough to fill a room with sound. Neodymium iron boron magnets deliver that crisp audio, while dysprosium keeps them stable even when our phone heats up. The battery isn't just lithium. It's a chemical cocktail. Lithium cobalt oxide for the positive electrode, graphite for the negative, and a liquid electrolyte, all wrapped in aluminum casing. The chip that makes our phone smart? Pure silicon, treated with phosphorus and boron to conduct electricity. Scattered across the circuits are tiny flecks of gold, silver, copper, tantalum, platinum, and palladium. Each has a purpose: power management, conductivity, corrosion resistance. Tantalum, for instance, keeps our phone's microcapacitors running smoothly. Together, they make our phones powerful, fast, and remarkably efficient. Now, the part that holds it all together. Most phones use aluminum or magnesium alloys. Some high-end models even use titanium, all strong yet lightweight. It's sleek, durable, and deceptively simple. Modern materials engineering at its finest. What we are not so smart about. Here's a twist. While our technology is brilliant, the way we treat the planet that powers it, not so much. Think about it. Where do all the elements in our smartphone come from? Lithium from Chile, cobalt and tantalum from the Democratic Republic of Congo, gold from South Africa and other regions like China and Australia, tin from China, Indonesia, Peru, and Bolivia, indium from China, South Korea, Japan, and Canada, rare earths mostly from China. Some of these metals, like cobalt, tantalum, tin, and gold, are considered conflict minerals, mined under conditions that can involve child labor or fund armed groups. Our phones are basically a miniature United Nations of technology, a global web of materials, labor, and logistics. If something goes wrong in one country, the ripple spreads across the entire supply chain, hitting production, prices, and even access to technology worldwide. Could any country make a smartphone entirely within its borders? Every chip, magnet, and screen? Almost impossible. The mines, refineries, and factories simply don't all exist in one place. And here's a bigger problem. Mining all those materials comes at a real cost. Before it even reaches our hands, one smartphone generates about 55 kilograms of CO2. From mining and manufacturing to assembly and transport. And that's before we even turn it on. Now multiply that by millions of phone upgrades every year, and the CO2 emissions add up quickly. A Yale study found that many metals used in phones have no good substitutes. If neodymium, cobalt, indium, and tin become scarce, our phones would fail. Other critical metals like copper, chromium, and tantalum are essential for circuits and electronics. Modern phones rely on a fragile set of metals with no alternate plan. Right now, billions of smartphones are lying around unused, in drawers, cupboards, or even landfills. Globally, there could be as many as 10 billion dormant phones, each one a tiny treasure chest of gold, copper, and rare earths waiting to be reclaimed. Yet, only a small fraction of these materials are recycled. Experts estimate that about 1% of rare earth metals from electronics currently make it back into the supply chain. That's a huge missed opportunity for both the planet and for connecting people. Recycling or refurbishing just one phone can recover valuable metals like gold, copper, and rare earths. Save over 10 kilograms of CO2 emissions compared to making a new phone. The smartest thing we can do? Use our phones longer. Recycle responsibly. Support ethically sourced materials. Small actions add up, just like the tiny elements that make up our phones. Phones may seem high-tech, but they are built from very human stories. Labor, landscapes, and trade-offs. So next time we unlock our screens, let's remember, this isn't just a phone. It's a miniature version of our planet. Chemistry, energy, and human ingenuity all working together in the palm of our hand. And maybe the smartest thing we can do? Give those elements a second life. Before we line up for the next upgrade, we have to ask ourselves, are we really being smart about our smartphones? Don't forget to subscribe, like, and share for more educational videos. Happy learning! Thank you.